Alright, back again with another solutions video. Let's jump right into it. This is specific heat problems. So these are kind of new. It's a little bit different. It takes a little bit of time to get used to this, but I'll walk through these first four. Right, we got four right here, and then there's some on the back that I want you guys to do on your own. Right, so do 5 through 8 on your own, but I'll help you through 1 through 4. So yeah, grab your pens, grab your papers, and let's get right into it. First problem, what is the specific heat of a substance that absorbs 25,000 joules of heat when a sample of 454 grams of the substance increases in temperature from 10 to 70 degrees Celsius? All right. So first I want to show you where you can find this specific heat formula. All right. If you take your pages, let me zoom out some here. If you take your reference table, open it up to the first page, and right here, that is your thing. The Q stands for the quantity of heat energy. M stands for mass. This C is the specific heat, right? C is specific heat. And this is called delta T, right? This delta T. This delta stands for change. So this means change in temperature. A lot of college professors call this Q equals MCAT. They like to say it like that. So remember, this is your specific heat formula right here. Q equals MC delta T. Remember, delta means change in temperature. So I'm actually going to write that right here. I'll write it. Q equals MC delta T. All right, that's actually a capital C. Okay, so first off, what is the specific heat? So we're looking for our C. We're looking for our C of a substance that absorbs 25,000 joules of heat. All right, so that's heat energy right there. Joules is a unit of measure of energy. So we already know that this 25,000 right here goes to our Q. So let's start writing out our equation. 25,000 is equal to, when a sample of 454 grams, that's our mass, 454, and we're looking for our C, and our delta T, our change in temperature, is from 10 to 70. So from 10 to 70. And the way you do change in temperature, the way you do change, and for our change in temperature, what's the difference between 70 and 10? Well, it's 60. So that's going to be right there. You can't ever, and this is important to remember, but you can't ever have a negative number. It's just strictly the change in temperature. There's no negative numbers. So you'll see later on, there's a question dealing with negative degrees. Well, even then, our change in temperature is not going to be negative. But let's continue on with this problem right here. Okay, so we want to find our C, all right? So to do that, we're just going to simply do 25,000 divided by 454 times 60. And that's going to equal our C. So let's do that. 25,000 divided by 454 times 60. Close the parentheses. Our C is equal to 0.918. Go ahead and go about 3 decimal places with this one, all right? You'll see a lot on the reference table is 3 decimal places, so go ahead and stick with that. So we're gonna round off on the third one, okay? 1, 2, 3, round off on that one. Awesome. Next up, how many joules of heat energy are required to raise the temperature of 550 grams of water from 12 degrees Celsius to 28 degrees Celsius? Okay, so we're looking for joules of heat, so that's heat energy, so that's our Q. All right, we have 550 grams of water. That's raising it from 12 to 28. So 12 to 28 is a difference of 16. Oh, wait a minute, we're missing another thing here. The specific heat of water, well, that's actually given to us on our reference table. So we're looking at specific heat of water, C of water. Water is in its what state here? 12 degrees Celsius, 28 degrees Celsius. It's in a liquid state. It's not steam and it's not ice. It's liquid. So we're going to use 4.18. 4.18. And then we can just find Q. So 550 times 4.18 times 16 equals our Q. So this is the joules of heat. 36784. So 36,784 joules, right? That's a lowercase j. Or uppercase, really. Next. How much heat energy is needed to heat 25 grams of water from negative 45 degrees Celsius to negative 20 degrees Celsius? Okay. So we're looking for heat energy, so that's our Q. We have 25 grams of water. It's going from negative 45 to negative 20, so that's a difference of 25. This is negative, so it's actually going to be ice. So what's our specific heat for ice? Well, it's different than liquid. It's actually 2.05. This is important to remember. I like to think of this as sort of like what we were doing with the gas constant, right? It depended on the units we were looking at. Well, this specific heat of water depends on which phase it's in or which state of matter it's in. Ice, so a solid, a liquid, or a gas. It's different specific heats, so we want to use those different specific heats here. But this simply just plug and play 25 times 2.05 times 25, and we get Q is equal to 128.25 joules. 1,281.25 joules. All right. Last problem on the front page, and then you guys can do this on your own. How many joules of energy is needed to raise the temperature of 75 milliliters of water from 110 degrees Celsius to 131 degrees Celsius? Okay. Excuse me. All right. Again, joules of energy. So our Q, raise the temperature of 75 milliliters of water. Remember, 1 milliliter of water equals 1 gram. So every milliliter equals a gram. So this is 75 grams also. This is also 75 grams. From 110 to 131, that is a difference of 21. And then this is steam, right? Because it's above 100 degrees Celsius. This is steam, so 2.02 for steam. So we're going to use 2.02. That's our correct specific heat. 75 times 2.02 times 21. Our Q is equal to 3,181.5 joules. All right, very nice. Go ahead and try the back on your own. You should be able to do it using everything you learned from the front.